I'm gonna start recording, but we can wait like 2 more minutes maybe so that people can join.
That's good.
Okie dokie. So later on, our attendants will be able to watch the recap.
Okay, give it about 2 more minutes.
Sounds like a plan. I see people like joining in, so. I think we can start. Yeah. Are you ready?
Sounds good. Hello, everyone. It's great to connect with everyone tonight. We have a wonderful event today being hosted by one of our bootcamp managers as well as one of our instructors, Alex Baranski, who will be, demonstrating to us on our topic, readability counts and best practices in Python coding. So very excited to be here with Alex as well as Martina and all of you. And it's a pleasure to virtually meet with you. Before we do get started, I wanted to just reiterate some of the points Martina mentioned earlier. Some housekeeping items. Make sure that you take advantage of our chat. If you have, in the event that you have any questions or any points that you'd like repeated, we'd be more than happy to connect with you. Make sure you have that set to, would it be a host and all panelists, or should we just do it for everyone? I say we just do it for everyone.
Yeah, everyone's fine.
Yeah, everyone's fine. That way we're all able to see your questions in the event that, multiple individuals have the same question in mind. We want to make sure that we're able to address it and everyone can see the response. All right, so I'd like to just share my screen very quickly. I don't want to take so much time from Alex today, but I would like to share with you a bit more regarding the Academy. All right, can everyone see my screen?
Yes.
Awesome. So just to tell you a little bit about New York City Data Science Academy and who we are. First and foremost, New York City Data Science Academy is an educational training and career development institution and offering both an in-person and online data science bootcamp. Additionally, I brought you to this page just because I would love for all of you to become familiarized with everything that NYCDSA has to offer, stemming from boot camps to courses. We offer job reports, some of our hiring partners, blogs, related to students as well as corporate blogs, and a little bit more about us. So you can find more information about Alex and his background as well as myself. And this is great for anyone who is interested in pursuing something with the Academy in the future. We offer both a data science bootcamp, in-person and remote live, as mentioned, focusing on data science with machine learning. To mention, we are currently offering applications for September, which is our fall quarter, as well as our winter quarter, which will begin on December 27th. So we are actively receiving applications for those cohorts. Additionally, I did want to mention we've extended our deadline for our data science and machine learning online cohort, which is set to begin on August 16th. So although it does say August 9th, you still have the opportunity to participate and take advantage of our 10% discount. So keep that in mind for anyone who is interested in furthering the studies and just making that transition to further their career, and you're interested in learning more. Similar to what Alex will be speaking on today, you're on the right track, and we'd be more than happy to connect with you and interview you and get you through the admissions process, and hopefully have you join one of our cohorts. With that being said, please feel free to explore our website, and you can learn more in regards to, as I mentioned, our bootcamp, get familiarized with our curriculum, our options. We do offer the program in regards to 12 weeks, which is an in-person and remote live. Additionally, it is offered as an online full-time with 16 weeks, and it's offered at a part-time level at 24 weeks. So for someone who is looking to accommodate this into their schedule, this is definitely, well, we do have options that can accommodate your day-to-day. The admissions process is very simple. For those who are interested in furthering or beginning their career in data science, you first and foremost start off with an application, and you can do so by applying directly on our website. Additionally, once you've submitted that application, you can book your interview to meet with someone on the admissions team, and we will conduct your interview. And if all goes well, you will receive a technical assessment and receive a response regarding that application shortly after. As I mentioned, that deadline for the August class has been extended, and we are taking applications for the fall and December cohort. So please feel free to submit your application if this is something that you are interested in, and we'd be more than happy to connect with you. Additionally, in the event that you have any questions or would like to book an informational call or have any questions in regards to data science and how to get started, you can always shoot us an email to admissions@nycdatascience.com. We'd be more than happy to connect with you and book a call and discuss a bit more in regards to your interest and some possible next steps. But yes, please feel free to visit our site. It'll share more in regards to our data science with machine learning bootcamp, as well as our data analytics bootcamp. And of course, we do offer some professional development courses for those who are interested in something more specific. But again, I do appreciate everyone's attention today, and thank you so much for joining us. And without stealing any additional time from Alex, I do pass on the mic to Alex, and he'll show you today's webinar focused on best practices in Python coding. So I will stop sharing, and Alex, they're all yours.
Thank you, Noah, very much. Hello, everyone. Welcome. Welcome for the first timers. Welcome back for those of you who are joining us again. Today, we are going to be covering a session talking about best practices in Python coding. Hopefully, most of you are at least somewhat familiar with beginner Python. In fact, let me ask, how many, what level of experience do you guys have in Python? You can say beginner or intermediate. Maybe you could say how many years you have. Make sure you're sending to everyone. You select next to 2, and then you can type in. Valentine, hi, welcome back. Intermediate, okay, good. Cool, okay, so a lot of people who seem like, at least we have a bunch of people here that have experience, that's good. Beautiful. So I'm just gonna share my screen here to get started. This notebook here should have been shared with all of you. If you don't have access to it, don't worry about it. I will share it with you after the session. And so I've written this in a way that you can really follow along without me, although the recording of this will be shared as well. Yeah, sure, hold on, give me 1 second. I can see if I can find it on my, let me post it in the chat here for everyone who wants to. Let's see. And it's only letting me join from Google Drive. Give me 1 second and then we can get started. I will share this with Martina so she can share with you. While I'm doing this, can I know where everyone's dialing in from today? I'm in Brooklyn, in Williamsburg. Where are you guys coming from? Okay, Queens, Florida, Puerto Rico, very nice. Got some Jersey, Virginia, very nice. Looks like mostly US. Anyone from outside the US? Nigeria, welcome. Thanks for joining. All right. Bangladesh, cool. All right, so I've got this uploaded here. Let's see if I can. Share this with you all. Here it is. Interesting. They don't have a share file option on Zoom anymore. At least maybe in this webinar setting. There we go. Viewer, here we go. Okay. So I just shared the Jupyter notebook in chat. Thank you for bearing with us there. So if you'd like to download it and follow along with me, that's totally fine. If not, if you just want to watch the video here and watch my presentation, then you're welcome to do so as well. And you could follow along afterwards. Like I said, so the way I've written this is that it's very kind of it's very self-explanatory. Everything has sections where you can read about them. We're actually only going to cover the first half, which is probably the most important part of this notebook, but you guys are welcome to go through and finish the rest and follow along with the notebook to whoops. Gotta reopen my Jupyter notebook. So let's get started. I need to share my screen here. If you don't have Anaconda installed, you will not be able to open this. So if you don't have it installed, that's totally fine. I can help you afterwards. If you have questions about how to install Anaconda, there's plenty of tutorials online as well. Anaconda will install a bunch of Python distribution for you and install something called Jupyter Notebook, which is what we're in right now. Jupyter Notebook is a really useful tool for anyone coding or creating presentations that include code, and it allows you to write in a language called Markdown to format the notebook to make it look really nice. So we use this a lot in our instruction, and it's a great tool to use for work presentations or anything like that, or research papers even. I put a little blurb up here about our programs. We have our residential, online, and professional development courses, so residential and online boot camps. If you have any questions about anything, you can reach out to admissions or info at NYC Data Science Academy or nycdatascience.com, and we're happy to answer any questions. So the session we're going to talk about today, and why we're all here, is that everyone could probably improve a little bit on their coding skills. And we're not really going to talk so much about your technical skills in this session. We're going to talk more about best practices in Python. Okay, so when learning how to code, it's very important to use the correct grammar and the correct formatting when you're writing your code, right? So just like when you're learning a new language, it's possible to make sentences where you could understand what they're saying, but it's better to write with correct grammar and with being polite, right? Like there's different conventions that we use in society that make it easier to converse and to communicate with each other. And the same thing is true for Python. When we're writing code, we want to follow certain conventions so that the people we work with it will help them better understand what we're trying to do and what our code is doing, but also for your future self, not just when you're writing code right now. You want to make sure that your future self will be able to understand what you were doing and what you were working on. It could be a real pain to work on a project and then come back to it in a few months and have zero idea what you were doing. So it's very important to follow these conventions so that not only can others work with you very well, which makes you more marketable in the industry, but also you can work with yourself in the future, right? So, like I was saying, the key strengths of a programming language such as Python is how it can be used in a collaborative way, right? And that's very evident from all the different packages and libraries and modules that have been created and are open source that we could use together, so that you don't have to reinvent the wheel, which is a big part of why Python is so great, and other languages like R and Java and things like that, because we can take advantage of these other packages and modules that have been written, so that you don't have to write everything from scratch whenever you're trying to get started, right? And so it's really important to be able to write code that is easily interpretable when you're writing packages or modules, because when you use those, you need to know how to understand how to use them. Everyone needs to understand how to use them. So there are certain conventions we want to follow, okay? So Guido van Rossum, who is the creator of Python, once said that code is read much more often than it is written. And that's really, it seems very simple, but that's a really important thing to keep in mind when you're coding, right? So when code is going to be read so much more often than it's being written, because people are using everyone else's code. So we really want to keep that in mind when you're designing your code, because the success of your work may rely on how someone else can interpret it or use it, incorporate it into their own projects, right? So to help Python coders maintain kind of a universal standard of coding convention, this guy Van Rossum and other Python experts developed a series of documents called the Python Enhancement Proposals, or PEPs. We call them PEPs, okay? And it covers a whole range of different topics, including Python development, backwards compatibility, style, and debugging. And one of the most well-known PEP is the PEP 8 style guide for Python code. And if we check that out, PEP 8 style guide, it's really a whole bunch of rules that are written about how to code with the correct formatting, right? So here we can see what the correct versions are, and then they have some wrong versions, okay? And so this one is for how to space arguments and function definitions. We have, and when we're defining lists and things like that, right? So maximum line length, we're going to cover a lot of this stuff today. A break before or after a binary operator, all of these things are covered here. And if you are a serious coder and you code on a daily basis, or very actively in your work, I would recommend actually just reading through this, because it really can help improve your coding style quite significantly, and you'll look like a more expert programmer if you code in this style. So it's worth looking into this and reading through it. It's not super long, and you can find a lot of very interesting things from that. So another Python expert named Tim Peters actually summarized the key ideas or the key takeaways from this PEP, the PEPs, in a sort of Python poem. Okay, the poem itself is actually a PEP called PEP 20, and it's called the Zen of Python. And if we can actually get it in any Python environment by typing import this and running this. Okay, and this will output this Python poem for us. It'll return this to us. And from this poem, I've kind of gone through and picked a few of the most important ones that should come up a lot. And we're going to go through those and discuss those. Okay. So we can see here, beautiful is better than ugly, explicit is better than implicit, simple is better than complex. These are going to be the names of a lot of the sections that I have here. And again, we're only going to cover a few of these, but the rest of them are here for you to look through if you'd like to browse them yourself and play around and see some other examples. So we're going to start off with naming conventions. This is not specifically or explicitly mentioned in this Python poem here, the Zen of Python, but it is incorporated in beautiful is better than ugly, readability counts, simple is better than complex. A lot of different ones share the same sentiment as this good naming convention. So this is where I want to start. So there are a lot of different ways to name objects in Python, but some ways are definitely better than others, right? And some common paradigms of these are a single lowercase letter, a single uppercase letter. We have just straight up just a lowercase word. We have lowercase with multiple words separated by underscores. We have one uppercase word. We have uppercase words separated by underscores. And then we have things called camel case and mixed case. So capitalized words and mixed case. Before I move on to here, I'm going to talk about these different things and where they are used most often. So very rarely you use single uppercase variable names unless you're working with like a matrix. So if you're working with a matrix, like for example, if you're doing, if you're training a machine learning model, your matrix or your feature set is usually capital X, and that's just to indicate that you have a two-dimensional structure there and not like a column vector like your target would be if you're doing like multiple linear regression, for example. Single lowercase variable names can be used. Those are probably the ones you use most often, where you're just kind of writing something and you say, I want to say, X is equal to some list, right? Not super great to use these single letters variable names when you can avoid it. If you're writing stuff for yourself and you're testing things, it's super quick, and so you can use these single letter single lowercase variable names. But for the most part, when you're writing code that other people will see or code in a project, you should use much more descriptive names that are full words. Like for example, I could put my list here, or my list or something, right? And it's more descriptive and it helps to give context to what that value is. I'll give more example of that later. Lowercase and lowercase with underscores is kind of the situation you want to use, or the variable name you want to use if you have a word that you want to describe a variable with, or multiple words that you want to describe a variable with. Uppercase and uppercase with underscores is reserved for constants, okay? And when I say reserved, it doesn't mean that you can't call anything with an up. So I could say, uppercase is equal to the number 5, which actually would be a good usage of this because this is a constant. But so it's not going to tell me I can't do this. But for example, I can say like my string or something like this, or I can give a list. Maybe a list would be a more inappropriate data structure to use, or value. So there's no problem doing that. But these uppercase words are usually reserved for constants, like the speed of light, pi, anything else that is a constant, that's some value that isn't going to change. We also have these two, which are capitalized words and mixed case. These are actually not very often used in Python. This is a Java, very Java-like syntax or naming convention, and capitalized words is this can be used for classes. Okay, so if you have a class definition with multiple words in it, you want to capitalize each word in that variable name. Okay, but for the most part, we don't use mixed case at all. But capitalized words can be used for classes. Now, not to say that this can't be used, because again, you could say mixed case is equal to this isn't ideal. Totally fine, and it works. I can return this. However, it's not ideal, and it's kind of like I don't know. You get on a flight and you have your luggage, right? I mean, you should put your luggage in the storage, right, in the overhead storage. But you could just as easily sit on your luggage, and it would be uncomfortable for the flight, but it would work, right? So this is kind of like sitting on your luggage. When really what we would want to do is maybe we do something like this, right? This is more Python convention where we have words separated by underscore. Not a super big deal, but whatever you end up going with, consistency is really the key. So just make sure you're being consistent with whatever you choose. Now, there's some other naming conventions in Python that do have special meanings. Okay, and all of them have to do with this underscore. So if we use call something with an underscore preceding it, that usually is used to indicate a internal use indicator, and this is usually reserved for inside classes or inside modules, like defining variables inside modules. So, for example, if I have a module where I have some variable name called underscore single leading underscore, and I do this from module import star, which should import everything that's inside that module. It will import everything into my namespace. It will actually leave out these variables that have these underscores in front of them, and that includes functions, I believe. So any object that has a single underscore in front of it will essentially say, will indicate, don't import this because I don't really want you to have this. This is more of an internal thing that I'm using. For a single trailing underscore, this doesn't really have a special effect to it, but usually we use this when we want to call something that already has a name, right? So for example, this list here, the list is a function in Python, and you could see it because it's highlighted green here, okay? So if I say list is equal to this list here, and then I try to call the list function on, say, like a tuple or like a tuple here, I'm going to get an error because this list is no longer a function. It's now a list that I've overwritten the function with the list. So what's better to do, what you want to do is, if you have to use the name list or some name of some function like max or sum or min, or, I don't know, average isn't one, but maybe standard deviation. No, these are good. But if you do need to use these names, you should put a single underscore at the end of them, which will change the name, and that way you're not overwriting these functions. Okay, so very important to do that. A double leading underscore invokes something called name mangling, and this is for when we're working within classes. So within a class, you will define things called attributes, and attributes are just like variables that belong to an object, right? So for example, like if I say my list is equal to 1, 2, 3, 4 here, and then I look at my list and I put a period and then I type tab here. This is a collection of all the different methods I have available to this list, my list object here. Okay. Now these are methods; they're not single values; they're actually functions. Methods are functions that belong to a class. But the same idea is the same here, is that these are things that belong to this object, right? And so the same thing happens with just variables that belong to a certain object. They're called attributes. Now sometimes we want to define attributes within a class that they shouldn't be touched by the user, right? They're kind of internal. It's kind of under the hood kind of stuff. We don't want users playing around with these variables. So what we can do is we can add a double underscore in front of them, in front of the name of the attribute. And what that does, for example, we have this class called foobar. It takes this boo. If we have a variable called boo here with a double underscore, that actually becomes underscore foobar underscore underscore boo. So what it ends up doing is it takes the class name, adds an underscore in front of it, and then appends that to the beginning of the name, which makes it more difficult for people to access this hidden variable within the class that we've defined. So this name mangling can be very useful for preventing users from using variables that are not meant to be used or manipulated. And then finally, we have this double leading and trailing underscore. So an example of this would be the string method. And these are something called magic methods, or special methods. And these are special methods that we have that do certain things. Like, for example, let me do my list 1 and my list 2. Can someone tell me what happens when we add 2 lists together? And what is that called? What will happen when I add these 2 lists together? Okay, so append, you're on the right track there, Jessica. So it's not actually an append, but it's something called concatenation. Okay, so append indicates a mutating operation where we're actually changing one of these 2 lists. But what we actually get the result here, this is a completely new list, and neither of the earlier lists have been changed. Okay. But yes, you were absolutely on the right track here. So we can see here that my original two lists are unchanged, but we have this new list returned here. So this is called list concatenation. Now, how does Python know that when we use the the addition operator here, how does Python know that we want to concatenate these two lists? Well, there's a special method in the list class called add, and I can prove that by calling this method on my list one. And this is a more advanced Python here. So if you're not sure what's going on here, don't worry about it. But what I'm doing is I'm taking my list one, I'm calling this special method called add, and then I'm passing as an argument to this method my list two. And what this is doing is exactly this. This operator here is actually calling this method under the hood. So if we do this, we'll get the same exact answer. And this is actually really useful because we can change how, for example, the equivalency operator or the multiplication operator or the exponent operator, all of these things, how do they behave when we use them with things other than like floats or integers or strings, right? And we can define how they behave in our class using these things called special methods. These are not names that you want to invent. Like I don't want to make something called new method like this. That's not something I want to do. There are certain reserved special methods that we have to call on, and those are the things that we have to that we can use in our classes. So again, this is more advanced, but definitely useful when you are defining classes and want to manipulate your variables in there. Okay, so let's talk about some names to avoid. So you shouldn't ever use characters lowercase l, uppercase o, or uppercase I as single character variable names, because depending on the font that you use, they can be indistinguishable from the numbers 1 and 0. So these are really not great variables to use. If you need to use L, try to use uppercase L instead because it's less ambiguous. Also, I mentioned this before, but I'm going to mention it again. Don't use built-in function or class names as variable names. So you don't want to use max or sum or list or class. And I don't even know. I think if you do class here, which is a keyword, I think it'll give you an error because it's not going to allow you to store a value in a keyword. But things like list or sum or max, we want to add an underscore here if we can't choose a different name, because that way we'll change the name and we won't be overriding these functions that exist. So for example, I don't think let me use tuple here. So this tuple function will take some iterable and will convert it to a type tuple. If I take tuple and I say, here's my new tuple, and then I say tuple, and I try to do this again where I call this on some other thing, now this function is no longer a function, it's now actually a tuple. So I can look at the type of my tuple variable here. Oh, oops, sorry, a tuple. And you can see here it's actually a tuple now and not a function any longer. So like, for example, if I look at type of list, which is a function, we should get function back. It's giving us a type, but yeah, this is a function here, okay? Or it's also a class, but this will tell us that it's a type. So the takeaway here is that you don't want to give these names other values because they have values already. If I do want to get this casting function back, I actually have to restart my kernel to reset my namespace, which will give me back the original version of the function. So try not to do that. You want to add something like this to change it. For defining modules and packages or naming them, modules should have all lowercase names. So for example, import my module, something like this, right? That's totally fine. Python packages should follow the same convention, although use of underscores and packages and package names is discouraged. So we usually want to do things like sklearn or import, I don't know, like date time. These things we don't have underscores here when we have these packages. It's just not good convention. Okay. Just a quick aside: the difference between a package and a module. A module is, I can even just make one here. So I can say my module dot py. So a module is just a py file extension, which is just a text file with a py. And I can say, let's define some function add to, which will take some value, and then it will return that value plus 2. So that's a very simple function here. I'm going to save this. I can come back here and I can import my module. And now my module is imported. And now, for example, I can say, what is it called? Add to. Whoops. Add to. And let's do 5. Oh, I'm sorry. I didn't call my module. I need to say where this thing is, and it's located within my module. And so I can say within my module dot add to, and then I pass 5. It's going to give me back 7, right? So modules are a really good way of organizing your code, and I strongly recommend getting used to writing your own modules and using them to import into things like Jupyter notebooks. So, for example, if I had a data set and I need to prepare it, I need to like manipulate it and clean it and maybe do some transformations on it. I wouldn't want to do that and define all the functions required for that in a Jupyter notebook. That's like my final presentation. What I would really do is I would define a bunch of functions in a module and call those functions within my Jupyter notebook, or maybe in a separate cleaning script to keep my code a lot cleaner, right? So modules are really nice for compartmentalizing and organizing your code so that all of your code that's related to each other can be called from this one module. So I know, if I need my data cleaning stuff, I can say cleaning module and I can import that. Or if like I have like a graphing module that like has a whole bunch of graphing functions or something, or plotting functions. So really useful to do this. And I strongly recommend getting used to doing that because it will make your code a lot cleaner. Now, a package is like a module in that it contains a bunch of Python files or scripts, except that a package contains not just one Py file, but multiple. And it can contain other modules, other packages and things like that. And then there's different levels like, package and library, things like that, that you can use. Okay, so we've discussed the naming conventions. So variable and function names should be lowercase. Constants should be represented by all capital letters. And then I also want to I have a little aside here, which is that in general, the names I, J, and K, these variable names, should be reserved for representing index values. Okay, so I see this a lot where people say use I as like a counter variable, or they use X and Y. X is equal to 5, Y is equal to 10, X plus Y or whatever. Okay. If this is code that you're just testing out, it's okay. But if you have, definitely not for production level code, but if you have code that you're using and you're collaborating with people, you should use more descriptive variable names unless these variables are representing index values, okay? These names are appropriate for indices because they are kind of used as coordinates. And similarly, X, Y, and even Z can be used for coordinates in some sort of space, and those can be used in that way as well. That's acceptable, but you don't want to use X and Y for just any values, only these specific values that people who are more experienced in coding will kind of expect to see them be named that, okay? So similar to the PEP 8, I've given cells here that say bad and good, and some of them have like good and better, things like that. A lot of these cells aren't designed to be run. Like for example, here I'm overwriting the list function, so I don't want to necessarily do that. Some of the functions will, some of the cells will just return errors. So really, it's all about the content of the cell, not that it runs. Okay, just to give you a heads up. The good cells should all run. If they don't, then that's a problem, but they should run. So here we have a couple of bad conventions. So for example, here we have the wrong character choice. Here we have kind of too long of a variable name. It's, you don't want it to be too verbose here. We're overriding a list function here, and then here we have a capital V for our variable. I should mention that capitalized variable names are reserved for classes. Okay, so if I see me as a coder, if I see variable like this, I assume that this thing is a class because it starts with a capital V. Everything else should be lowercase. Here we have a function that we defined, and we're calling it func. What it does is it multiplies some argument by 2 and returns that. But you don't want to give your your functions this name. This is not very descriptive. So give your functions descriptive names so that people will know, oh, that's what this is doing. Is it's returning, it's splitting something, or it's stripping, or it's I don't know, enumerating, for example, like here, right? So you want to give your functions descriptive names. Now here we have a for loop where we're iterating over this list Z. If you guys are familiar with the enumerate function, it's really useful. I'll give you a quick demonstration here. So if we look at enumerate of Z, what it does is it gives us a list of tuples here where the first element is the index and the second element is the value itself. So in essence, what it's doing is it's giving you each value with the index packaged with it, which could be very useful for when we're iterating like this, because we can keep track of what index we're on. The reason I'm converting this to a list, by the way, instead of just returning it like this, is because this is something called a generator, which has to do with memory efficiency. I'm not going to go into that. But if you want to look and see what the contents are, you can do this and it will convert it to a list for you. So here we're unpacking each of the elements in enumerate into X and Y. X will be our index and Y will be our value, but that's not very descriptive. Z is not a great name and X and Y are not great names in this case. So it's very difficult to remember what X and Y are within the for loop. But this is just one line of a for loop. You could imagine a for loop having many lines, tens of, hopefully not hundreds of lines, but tens of lines maybe, where you could forget what your X means and what your Y means because these names are not appropriate. So let's look at some good examples. Here we have a tax, price, and a total price variables. Now, there's nothing preventing me from saying X is equal to 0.125, Y is equal to maybe 50, and then Z is equal to Y plus Y times X, right? Now, I already kind of gave this away, and I tried to change this to a 50 instead of a 49.99. But if I had shown this to you and said, all right, what are we doing here, right? I would bet that many of you wouldn't be able to give me the correct answer. Maybe some of you would. But this really, I think, emphasizes the necessity and like the value of giving correct or appropriate variable names, or descriptive variable names to your variables here, because without those, there's no context here, right? I don't really know what's going on. I'm just kind of, finding the product of two numbers and summing it with something else. But here it's very clear what's going on, right? Immediately I know exactly what we're trying to do. And so it's very powerful to give these variables appropriate names. So make sure you're doing that when you are defining variables. Here we have pi and speed of light. These are both constants, so I'm giving them capitalized names. Here we have a function called price after tax, which hopefully is self-explanatory, and it takes these two arguments here. And then I have a short little thing of docstring, which we'll talk about in a little bit. And then here I have an example list, which I called X list. And then I'm unpacking my enumerate object in each element of my enumerate object, I should say, into a variable called index and a variable called val. And this should actually be index here, not I. Okay. So what's good about this is that now within my for loop, let's say I have a whole bunch of lines here. Later on, instead of calling X and Y, I would maybe forget what Y is, what X is. Now I can say what my index is and what my value is, and it's immediately I understand what I'm talking about, and it's much easier to remember what I'm doing and what my thought process and my logical process is. Okay, so very important to adhere to these naming conventions. Okay, let's move on to classes. This is more advanced, so if you aren't familiar with defining classes, just try to absorb the naming conventions so that you can use that later on when you learn. So really the idea here is that there's a bunch of naming conventions that we use in class definition. So for example, here, this is the name of our class. We should have a capitalized words here. So we have the capitalized words or a single word that's capitalized. So we don't want to do this mixed case. This is again a Java convention. We would want to capitalize P here if we wanted to make this a class in Python. There's a few different things here that I want to point out. One is that we're using this argument name called object or obj. Really what is appropriate is using something called self here. Self is the convention that's used for the first argument in these methods within a function, within a class. So make sure you're using self here. Now you can use obj. There's nothing wrong with this. You're not going to get an error, but the overwhelming convention is to use self here rather than using anything else. So make sure to use self. If you have two different object references within your method, you would want to use self and other here. Other is the name of any other object that you're working with in a method. And notice, by the way, we're actually defining our EQ special method in this case, where we're comparing two different things to say whether or not these two objects are equivalent. So if I've defined this Python vector and I made like, some pyvec1 and then pyvec2, if I use the equivalency operator here to check if these two things are equivalent, it would call this method, right? So the same thing here is pyvec1 dot EQ and then pyvec2. So these two are equivalent here, and I just wanted to give that little note there so you could see how this special name method definition is happening. Here I'm defining a new magic method or a special method. You don't want to do this, right? So you only want to use the ones that are existing. This is even more advanced. So this is something called a decorator, and this is something called a class method. A class method is like a new constructor, meaning it's like another way to define an object of some class. And so if we want to define that within a class, we can add this decorator, which essentially takes a method or a function and returns a different function, kind of changes it for you. And then the first argument in a class method should be CLS, standing for the class, similar to how we have self here for the object, right? It should be self. We have class, CLS for the class, okay? And this is just incorrect because we're using some arg here and it should be CLS. And then here's just another weird name that I've given a class that is the wrong naming convention. So let's check out a good class. So here we have a vector class, starts with a capital V and it's one word, so it looks good. I'm using self here as my first argument in my method. I'm using self and other, which is good. I also have a bunch of documentation here, which is good for explaining what's going on. Again, we're going to talk about documentation right here. And here I'm using CLS and then CLS down here as well. Okay. Something else that I did up here is we have a try except. If you guys are familiar with try excepts, these are ways of handling errors and passing them, or handling errors and preventing the error from halting or terminating your code. So what we could do in this try is we try some code. If any type of error is raised here, we go to the except and then we do something in here. Okay. And this, if the error is caught, we don't stop our code. Whereas normally, for example, if I do like 1 divided by 0 and then I try to print, does this print? We're going to get this error, the zero division error, and then it's not going to print this line because our code will halt because we were encountering an error. However, if I do try, and then I could say x is equal to this, and then I can do except. Except, and then I'm just going to pass here. We can see here that, or actually I'll print out an error occurred so we can, an error occurred. So we can see here that it tries to do this zero division, which obviously it can't work. And then that gets caught. We go to the except. The except is going to print out that an error occurred. And then we're also going to print this out because our code doesn't terminate, right? So really important, especially in tasks that are automating things, you need to make sure you have correct error handling. Otherwise, your whole automated script will halt, and that's not what you want to happen, especially if you're on vacation or something. Funny anecdote, I had an issue with one of my scripts once where for our instructors at the Academy, I had a script that is running currently that emails everyone what their schedule is for the week on Sunday. And I implemented this, and I meant for it to send out on 5 p.m. on Sundays. And I messed up my scheduling, and it started sending out emails every minute on 5 o'clock on Sunday, which was not what I wanted to do. And I apologize to our instructors for that happening. But I actually had to introduce an error in my automation script and push that in order to get the code to stop running. Because the script was running on a server on campus. So anyway, so just kind of funny. But so errors can be useful sometimes when you want to break things. All right, so let's talk about this. So we finished with the good example here. Let's move on to the documentation. So this, if you can take anything away from this workshop, it should be naming conventions and documentation. If you can get those down and really master those, it really makes a huge difference in your marketability, because people hiring employers, I should say, employers will be looking for people that can work well on a team or within their organization, right? So if you can show that you have interpretable names, you have good documentation, you can explain what work you've done, if you can do all that and show that you can do that in a very strong way, you may have an edge over someone who is quantitatively stronger, technically stronger than you are. So really important to make sure that your communication skills and your documentation and naming conventions are really solid, because that can make a huge difference in the hiring process if you're looking to move into this field or if you're trying to move up or anything like that. So documentation in coding is kind of like a mini instruction manual, okay? So what you want to do is kind of explain what your code is doing with comments, or what a function or some object is meant to do with something called Docstring, okay? Code commenting is a great habit when you want to explain your thought process or what a certain piece of code is doing, but be careful not to over comment your code. I've seen code where it's just like lines and lines of comments, and it really makes it's very difficult to parse through what's going on. So really you want to keep your comments to like a single or 2 lines max, and they should be kind of short flags of kind of what's going on, okay? So Docstring is like the mini instruction manual that I was explaining before. It's what you want to do is you want to explain what a function does and how to use it, and not really how the function works, not like if you don't want to explain that there's like some recursion or that it's you calling this other function, right? Everyone always wants to brag when they're writing really sophisticated code that took them a long time, but the Docstring should talk about what the function does and how you should use it. That should be it, okay? And then also maybe examples, or certain examples of when you could use things. For example, if I go to data frame, let's do let's look at pd.merge actually. If you're not familiar with looking at reading through documentation, I strongly suggest getting used to it. It's such a lifesaver when you are working on code, to be able to look up this documentation, see what all these arguments mean, what their default arguments are, what the argument should be. There's usually some examples down here, right? So they have some examples included as well, which can be very helpful. Also, Stack Overflow is incredibly important as well. So this Docstring can actually also be let me do I don't know if it's going to let me do this, but let's see. No, it's not going to like it. So let me do something else here. So let's do max. So if I type the max function here, and I put my cursor inside and I type shift and tab at the same time, it's going to pop up with this Docstring here, which shows us the different arguments, and if there's any default arguments, and also the Docstring here. Okay, so this can be really useful. We can also access this by putting a question mark before the function and running it, and it will pull up the Docstring down here. Now, when we're writing code ourselves, either classes or functions, it's really important to add Docstring to explain what these things do. And the way we add Docstring is at the beginning of the function or the class definition, we have these 3 quotes. This is something called a long string. Okay, so this long string contains my my documentation. I have a short blurb here about what the class represents. I have the different attributes of this class, and then I have what the different methods are and what they do. Okay, now that's for a class definition. This is kind of how you would format what your documentation would do. Maybe also add some examples down here, so I could put examples, and then maybe write some coding examples as well, which would be helpful. For a function or a method, you use the same triple quotes, which adds this long string, and then here we have, for my function, I have what the function does, what the arguments are and the types of each of these arguments, and then what it returns, okay, and the type of the return. Okay, so this is really important for when you're defining functions, because it can tell people what does the function expect as input, what should you expect as output, and what the function is actually doing. So writing this very descriptive Docstring can be very helpful in making sure that other people understand how to use your code. So I've written Docstring here for a number of these methods that I have here. I kind of went overboard with the documentation a little bit. For example, the string method. What this does, the special name method str, it takes an object and it converts it into a string representation. So by default, if you don't define this method, it'll return something as like class name dot, some gibberish at location something. So it kind of looks like something like this. Kind of looks like this, where it says like, class name dot something at whatever, or main, and that's not very descriptive. But if we define this string method, what happens is it will return whatever string we want to return to describe that object, instead of its location in memory, which is not usually super useful to us as programmers. But this is a pretty self-explanatory method. Most people know what this does, so you really probably don't need to add this level of docstring to this, if any, because it's just kind of widely known. It's kind of like adding docstring for print or something, or some very simple method or function that it's very clear what's going on. But always better safe than sorry to define these things. Here we have a function that walks the dog. All it does is just prints that we walk the dog's name. And then here I'm returning how many years old the dog is in dog years by multiplying the age of the dog by 7. And then if we run this, we can see I'm defining this Fido object, which is we're making use of this dog constructor. I'm going to print out what Fido is, which is this is what I call. So let me actually show you. So this is what the object looks like if I just return it. We have this main dog at some location in memory. If I print, or if I convert this to a string, I can use the string casting function. What it's going to do is it's going to say name of the dog, the breed, age 6, right? So, or age, whatever the age is. So this is actually calling this special name method to convert this object into a string version of it, which is what's happening here. When I say print of Fido, this is going to automatically convert this to a string type, which is going to call this string method for us and then print it out for us. And then I'm calling these two methods, walk the dog and dog years, to get, I'm walking the dog, and then I'm also printing out how old the dog is in dog years, which is 42 in this case. We can access our documentation the same way we do access the documentation for any other function, right? So if I do Shift Tab in here, or I put a question mark and then do it like this, I can get the documentation. Look, it's right here, right? So here is my documentation for the class. It even shows the documentation for the init method, which is this up here. Get rid of this, which is this method here, which defines how the object is going to be initialized. So, these are the different attributes. We have a name attribute, an age attribute, and a breed attribute, and so on. Okay. Let's move on to commenting. This is an example of, I didn't give a wrong example here, but anything where you have comments that are more than 3 lines long probably is and maybe like on every line is probably not great. Here I have a function factorial, which calls itself recursively. This is a recursive function that's going to tell me what the factorial is of some value. So of 5, or wow, that's a huge factorial, but factorial of 5 is 120, right? Or that's correct. And what I'm doing here is I'm going to specify that this is one base case. This is actually another base case as well, and then also that this is the recursive call. So I'm just kind of explaining kind of what's going on here, adding some annotation to what my thought process is and what's going on in each level in the code. Okay. So a few other things that I want to cover here. So let's we will go a little bit over. If you guys have to go, that's totally fine. I won't be offended if you leave early, or on time, I should say, because I'm the one going over. But we should take maybe another 15 minutes and we'll wrap up. So the next, so that's naming convention, and that was really kind of covering a bunch of different aphorisms, in this Python poem. The next one, or it's not going to show us the second time I import it. So let me go back up here and show you. So the first aphorism here is beautiful is better than ugly. And I think this is a really elegant one, even though it's, again, a lot of these are very self-explanatory, but it's really important to write beautiful code, and beautiful meaning concise. Oh, it means many different things. So let's talk about what beautiful code looks like. So the syntax is separated into logical sections. There aren't too many characters on a single line. We're going to talk about the max characters per line. The indentation is correct. That's actually necessary for Python because Python doesn't have any terminating characters or enclosing brackets for the most part. So you need to use correct indentation to make sure you explain the scope of your code. There's correct and consistent spacing between arguments and lists and things like that. And all this is important because it helps people read your code more easily, right? And that's something that you always want to do, is make sure that your code is more easily read. If you read a lot of code and you look at something like this with no spaces in between it, it's very difficult to parse this, and it can take much longer, than something else that's split into logical sections. So let's go look at this. So make sure you are cognizant of how your code looks on the screen. Okay. So here in this case, we have inconsistent spacing. So you should always have one space before and after an operator for the most part. Here I'm being inconsistent about this. Here I have no spaces. Here there's no space here, but there's a space here. Make sure that you're putting spaces, consistent spacing between your operators. Here I have a function that I've defined, and I've put a space between the function name and the arguments. I see this happen a lot where people say like sum and then something like this, right? This will work, but it's really not good practice. You want to make sure that these are next to each other. Don't put a space in between your function name and the arguments. What this is going to do is it's going to count the number of words in some sentence, and it's going to replace punctuation for us, which is nice. So we don't want to, for example, if a sentence ends with some word, we don't want that to be a specific word. Like, for example, this is a sentence, another sentence, blah, 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 right? So the issue here is that this is one word according to how I'm splitting my string, and this is a second word because this sentence here doesn't end with the character period. Okay, so we want to remove all the punctuation, or at least comma and period here, so that we get these unique words. So we have a question here. Are there pip 8 libraries that can sit on top of Jupyter Notebook and make code conform to pip 8 standard, or the pip 8 standard? That's a good question. I'm not familiar with any import packages that kind of force you to conform to these standards. A lot of them are more like conventions. So it's not like it's going to raise an error, but it is better to follow these, and so you should try to adhere to them as much as possible. There are things like widgets that you can add, and different kind of things that you could add on, like add-ons and things like that. To be honest, I don't play around with a lot of them, but I know that some people do, and that there are some interesting ones. So there might be something out there that exists. Good question. So notice that in this function that I've defined here, I don't have any spaces between the lines. Everything is kind of jumbled together. I have no spaces between my operators, and it's kind of difficult to parse what's going on in this whole thing here. So I have the same exact thing here. This is the same code, except I've added documentation, I've added comments, I've added spaces, logical spaces between the code here. Okay, so here I have two sentences here, or two strings, and I've defined them separately. I've also added these comments, and then I'm going to concatenate them into one single string, which I'm calling full sentence here. And then I'm going to define this function here. I've added Docstring, and notice that I've now taken these for loops that I have here, and I've separated them into logical sections, right? So the first thing is, hey, I want to remove the punctuation, so I'm going to do that first, and then after that, I'm going to make a dictionary and then add all of my words to my dictionary and add one if it doesn't exist, or I'm sorry, add the word if it doesn't exist in the dictionary, or add one to it if it does exist. And so this should return a dictionary that has the frequency of each of these words that are in the sentence. Now notice I left out the exclamation here, so we have ton with exclamation point at the end as a single word. But if ton was somewhere else in this sentence, I wouldn't have caught that. So it's very important to make sure you test these and make sure that you're hitting all the cases that is appropriate. So the main takeaway here is that it's very difficult to delineate what the steps are in this solution. But here it's much clearer because I've separated these into logical sections, which makes it much easier for my brain to say, all right, I'm going to start with this. Let me understand what's going on here. Okay, cool. Sounds good. Let's move on to this part now, right? And so being able to do that and kind of dictate where your reader should be stopping and reading and kind of processing can be a very effective way at making your code more interpretable. So the next thing we're going to talk about are maximum characters on a line. Don't be the person that writes code that's super long like this, okay? Because if you read this, it's really, really difficult to parse this. And so PEP 8 suggests no more than 79 characters on a single line. There's a number of different reasons for this. I think the main one is that there were standard screen sizes, and you don't want to have more than 79 characters because then it would kind of go to a new line. But really, the best way to think about this is that when you're writing an expression or some sort of statement, think about it as a sentence, right? So read it out to yourself in English or whatever language you speak. So here I'm saying number 1 times number 2 for number 1 in range 100, 1000 for number 2 in range 100, 1000. Now, if I said that out loud, it sounds like a run-on sentence. So what I can do is I can separate these into multiple lines by saying, for example, here, 3-digit products is equal to number 1 times number 2 for each number 1 in num range 1 for each number 2 in num range 2, right? So splitting this up into multiple lines is like making different sentences for a run-on sentence. So I think that's one of the best ways to split up expressions into multiple lines is if you read it and it sounds like a run-on sentence. We also have, when we're splitting up some sort of statement that contains operators, we want to make sure that the operator precedes the operand, okay? So here we have not what we want to do, where we have kind of this plus and minus on one line. We want to have the this value, and then we have the operator precedes the operand, okay? Similarly with functions, when we have these different arguments, if we want to put the arguments on different lines, make sure that they're lined up so that it's nice and neat like this. Okay, let's move on to keywords. So there's a lot of keywords in Python that make our code easier to read. So some examples are and, or, not, and is. So this is really useful because we can kind of start thinking about code in human language rather than in kind of machine language, machine code language. So using these words can make it, you can write code where you can kind of read it as a sentence, and it makes it a lot easier to interpret. Okay, so the coding grammar is easier to digest. So here I have some conditions that I haven't defined, but we're saying I want if condition 1 and condition 2 or not condition 3, then I want to print something out. And then I have some function that says is correct A and B is equal to 10 or S is equal to include. Then I can say could be better, right? So these things are not great. We want to try to avoid using these ampersands and pipes unless we need to for other objects, like for example arrays and series, which are objects from data structures from NumPy and Pandas respectively. Those require using these special bitwise operators because of the way that those objects are constructed. So a better way to do this is to say something like if condition 1 and condition 2 or not condition 3, right? So using these words, these English words, makes the reading of this condition a lot easier, and it just makes it more natural to read. So here again we have is correct A and B is equal to 10 or S is equal to include. Now really I should be a lot more explicit here. I would probably want to wrap these because these operators do, these keywords do have a priority, right? They have an order of operations. So I'm not exactly sure what they are off the top of my head. You could probably look it up, but I would want to make sure that these are run in the order that I want them to be run, right? So I would probably add these parentheses here. Something else that I want to point out really quickly is that I see this a lot, where we have, for example, well, this is the example. We have some condition 1 is equal to some value true and condition 2 is equal to some value false, right? And then I see people say condition 1 not equal to false and condition is false, right? Or I say like if condition 1 is equal to true, right? And then I print something or I do something. Now this will work. There's nothing wrong with doing this, but it's not as Pythonic as a better solution would be. A better solution would just be to say if condition 1. And the reason why is because this expression here needs to evaluate to be some Boolean value, either a true or false, right? So condition 1 is equal to true, does evaluate to be true, but condition 1 is already true, right? This condition 1 thing already is true. So I don't have to compare it to the value true. I can just say if condition 1, and that will work. So the idea here is use the truth value of the object itself for the condition in an if statement, if it's possible. So some other examples here are using objects and the truth value of objects. And when I say the truth value of objects, that means like what their Boolean representation is. So for example, Boolean of 1 is true, and Boolean of 0 is false. So I'm converting these integers into Boolean values. I get 1 is true and false is 0 is false. Anything non-zero will be true, actually. So any non-zero value here will be true. And if you think about this, it's true for all objects pretty much. So for example, a list, any non-empty list will have a Boolean value of true. Any empty list will have a Boolean value of false. Any non-empty string will have a Boolean a value of true. Any empty list will have any empty string will have a Boolean value of false. Okay, so this one's kind of confusing. You might expect this to be false to convert this to a false, but this is actually true because this is a non-empty string. So this is a false. This is actually a true. And then we can also look at lists here. That is a false. This is a non-empty list, so it's a true. So what I can do here is I can use the truth values of these different objects to write my code. So for example, here I have if empty list, which should be a false, or 0 int, which should be a false, or empty string, which should be a false. Okay. And then I have if non-empty list and non-0 int and non-empty string. This will print because these are all truth values. And then we also have here condition 1 or condition true, and these will print out. Okay, so think about this when you're writing these control flows, this control flows code. Try to use the truth value of these objects rather than comparing them to other things. Now, this, it might be better to say something, for example, if empty list equal to empty list like this, and then I want to print the list is empty. This might be more interpretable than just saying if empty list or if not empty list, for example. If not empty list will negate a false, which would tell us that it is empty. And this is probably not the best way to go, but there are situations where you might want to use the truth value of the objects themselves rather than comparing them with other objects. Okay, and the last thing I want to talk about is a really long portion of this, but really you don't have to understand this code beyond the fact that this is one function here that I've defined, and this is using multiple different functions that I've kind of broken the main function up into different pieces. Okay, so this is using breaking a function, some operation up into many different functions. Is these different functions are called helper functions. Okay, and helper functions are really useful when you have a long function here that does a bunch of stuff that maybe is repeated, right? So for example, what this function is doing is it's in this case, the function is signing up students for some courses. Okay, I wrote this a while ago, so I'm not as familiar with it as I used to be. But the idea here is that we're going to look through this and see if the student is already signed up for the class. Is there a conflict? Things like that. Okay. Now, there's a number of different operations here that are repeated. Okay, and because of those repeated operations, I can define, for example, a yes/no checker, right? So, for example, here there's a number of different places here where I say, "Did you want to? Would you like to drop a course?" Right? So that's a yes/no. And then I believe here, sorry, I didn't understand your input. Please respond with a yes or no. So I have a number of different prompts here where I'm asking the user to enter in yes or no. Rather than having to check all of these different things, I can define a function called yes/no checker that takes some prompt as an input, and then it's going to check it's going to ask the user, here's the prompt, and then it's going to get some answer back. And if the answer is in Y or yes or an N or no, it's going to return true or false. And then it's going to say, otherwise it's going to say, hey, I didn't get it, please try again. Okay. So and then what I can do here is I can use the YN checker. For example, here. So I'm saying YN checker, and then I get some response. And then I'm saying if response, because this should be a true or false responded. And if the response is true, then I want to go and drop a course and do whatever I want to do. Somewhere else I use it is, let's see, yes or no checker right here as well. So if I say, would you like to register for another course, right? So if I do that, then it's going to go back up and continue this while loop. So these helper functions are really, really important to not necessarily make the code run better, but to make the overall problem more digestible. So you can go through and you can say, all right, I understand what this function does. I understand what this function does. I understand what this function does. And then once I'm done with that, I can go through and I can read the main function and say, hey, okay, well, I'm calling this course dropper function in this function. So what did that one do? Oh, yeah, right, it did this, right? And so I can give documentation for this specifically, and I can do these different things. So using these helper functions can help a lot to break down a much larger problem into smaller ones, and we can kind of go through them and digest them individually to make them a lot easier. Okay. And with that, that is where we're going to end today. There's a number of other great aphorisms here that you should look into, like explicit is better than implicit. We also have simpler is better than complex. I have a number of examples here that you guys are welcome to go through and look at. And like I said, this is all self-sufficient. You could read through this and you could follow along, even though I won't be there to guide you. If you liked what you saw today, we run these webinars pretty often, and luckily I'm here sometimes to host them. But we do run them quite often, so you're welcome to come back and just keep an eye out on our social media and our emails to see when our next one will be. And if you're interested in learning more, deeper than what we're doing here, you can look into our bootcamp programs or our professional development courses. We have a number of different programs at different paces and different levels of depth and things like that, and at different price points. So, this is a really good time to upskill yourself because of the shift in the industry right now and the hiring landscape. Hopefully, with COVID, clearing up, hopefully sooner rather than later. We'll see a boom in new hires and businesses growing back. So always good to continue to improve yourself and do some professional development. So more than welcome to reach out to us. We're happy to answer any questions. I'm happy to. I'll actually put my number in the my email in the chat here. And so you guys are free to reach out to me for any questions about our program or just about this notebook in general. Thank you all for joining. For those of you who are still here, thank you for staying with me and bearing with me. If anyone has any questions right now, I would be happy to answer them if you want to type them in the chat. Otherwise, look out for our recording of the session, and you should have the notebook as well that Martina has posted in the chat here, and I will put it down again in case you missed it.
Yes, once the webinar is over, maybe like tomorrow morning, I'll send out the video recording and materials, so you guys will have everything in one file or email. Yeah, so
Beautiful.
If you have questions, feel free to ask.
Shakuntala, do you have a question? I see your hand is raised.
And just make sure that when you register to the event, you use the right email because it's gonna go to that email. Yeah.
Tab versus spaces. That's a good question. So in some text editors, when you press tab, it will actually, I'll actually give you an example here. So for example, here, if I save this as, let me just do this, test.py. So I'm saving this as a py file, and I can say define, some function, and then take some argument. Now, if I do a tab here, this tab is actually, it's hard to see, but there's 4 dots here, and those 4 dots are a tab is 4 spaces. So in this Sublime, in this Sublime text editor that I'm using here, when I press tab, it will actually convert these into spaces. And this is usually because some Python packages really complain if you have a combination of. So for example, if I do this, let me make a bunch of these, and then I convert these all into. I can actually go to view and then indentation and then convert indentation to tabs. And you can see now that they're lines as opposed to these little dots, right? So the dot is a space and the line is a tab. But if you have mixed some spaces and some tabs, some Python packages will actually complain. So you want to try to make sure that they're all consistent. And in a text editor like this, I can go to view, indentation, convert indentation to spaces. I like just using spaces, but you should try to probably use tab here rather than 4 spaces each time, because that can get kind of annoying. Any other questions? Don't be shy. Okay. Well, thank you again for joining us. I hope to see you next time at our next webinar. I hope you learned something useful, and I really make sure you're using these good Python coding practices in your own work and going forward, writing good documentation, using good naming conventions. They will really help to improve your code readability, and I hope to see you use them in your work. So thank you for joining us, and we'll see you soon.
Thank you, guys.
Thank you, Alex.
I'm gonna close it now.